we're going to start algebra tiles, and so to do that we need to talk about the basics before we actually start using the tiles to solve algebra problems. Most algebra tiles look something like this. You have a small yellow rectangle in green and a blue square, and then you have the same thing in red, but it doesn't have to be those colors. It's just the shapes that are kind of more important than the colors. So the yellow square would represent 1. The green rectangle represents x. The blue square represents x squared. Sorry, the blue square, yeah. The red square represents -1. The red rectangle represents -x. And the red square represents -x squared. So those are the basics of what you should have for algebra tiles. So if we have a problem that looks like this, and you have 2 yellows plus 3 yellows, well, what does it equal? Well, the first set's 2, and the second set's 3, so that's just 5. What if we have 1 red plus 3 reds? Well, so that's going to be -1 plus -3, which is -4. Then if we have 2 reds plus 3 yellows, this is -2 plus +3, which is 1. If you've noticed, I've marked out some of them because those are 0 pairs. If you have -1 plus a +1, you get a 0, so it goes away. So whenever you do that, it's kind of like they cancel out each other and you're left with 1 positive. But what about subtraction? Well, subtraction is simply adding the opposite number. So 3 minus 2 is going to be 3 plus -2. Then you can work those just like the other ones, with 3 yellows and 2 reds being added together. Again, some of them cancel out, and you're left with 1 positive. But wait a minute. Hopefully you notice that -2 plus 3 is 1, and 3 minus 2 is 1, so they must be equal to each other. And this is really interesting because you can use the commutative property and switch that -2 with the 3, and you get the same answer. Now here's what we have. We have these green rectangles, and most of the people think that the green rectangles are just 3 because that's what they look like. They look like you've just put 3 yellow pieces in a row and called it a variable. So let's think about, what does the word variable mean? Well, if I say, if I say something varies, then something varies, it's changing. So the word variable is all about change. Yes, on the screen, the X rectangle looks like it's 3 units, but it's actually representing any number that I want it to be. I can change that number depending on the problem. So a variable represents a number that changes. For example, the amount of money I make changes as I work more hours. So what's changing here the most? Well, let's just look at one thing that's changing here. That's going to be the amount of money. So I could say that I make, $15 an hour. So my money is changing based on how many hours I work. Now if I work 2 hours, it would look like 2x, and you would have 2 rectangles, and each rectangle is worth 1x. Do not get this confused with exponents, okay? This is x plus x, and x squared is x times x. So don't get those too confused. A lot of us do that. So if I have 2x plus 3, I would draw it out as 2x plus 3, like this. Notice the x's are totally different from the yellow ones. They're not in the same world, okay? So what about x times x, which is what an exponent is, and what we just got done working with? So when we multiply using algebra tiles, we create this type of table, and it's going to allow us to make what you would have done in previous grades, like an array. So you put the X tile on one side and then on the other. And then basically you just fill in that middle piece. So we have X times X, and it gives us X squared. Okay? And that's all I got. So be ready to work on that for in class tomorrow or today, whenever we do it.